Hello, everyone. Good morning or good afternoon, depending on where you are joining us from. My name is Valeria Meneses, and as part of the marketing team at FIRE, I give you the warmest welcome to today's webinar. We will be discussing how to overcome the challenges of fire safety in office and commercial buildings. A few comments that I need to tell and to share with you before we start. As it has been for the last few webinars, we are now testing a new feature from WebEx in which you are able to select captions in different languages. Actually, I just need to do one quick thing, as I have been informed that the selected language is Spanish. And in this case, we're speaking English. So now it should be working. You can select different language by just going to the bottom left icon that is on the screen. And then you can see there the whole list of languages that are available for the automatic translation. And of course, you can also customize the font so that it doesn't take too much of the screen and you are able to follow up with the slides that we are presenting. In case that you are joining us from a mobile phone, you can also use this function, and it's quite similar, very simple. You go to the bottom three dots, and then you can see the option of closed captions. The default language is English, but you can also choose different languages from the list. Again, this is a new feature from WebEx. It has been working quite all right for the last few webinars, but we are always interested in receiving your feedback. So we would really appreciate if you could take some time at the end of the webinar to respond a very brief survey to evaluate these and of course also the content of the presentation. Some other considerations, as usual, this webinar is being recorded. That's why everyone's microphones are muted so that we can guarantee the quality of the audio. But of course, you are more than welcome to write your questions or any comments that you have for the presenter in the Q&A section. We will try to go through all of the questions at the end of the presentation, and if there is no time available, we will reach out later to follow up on your doubts. And also very briefly from my side, I will also want to invite all of you to follow us on our communication channel so that you do not miss any of our next webinars, that you are updated with the latest information. So please subscribe to our new newsletter. We recently moved to a central-based newsletter, so you have to register scanning this QR code so that you make sure that you are receiving all of our emails. And also, we have been, since the beginning of the year, on a new LinkedIn channel called Bosch Life Safety Systems. So please scan the QR code to make sure that you follow us on that channel as well. And now, with no further ado, I present to you my colleague, Florine Bukur, Application Design Manager, and the presenter of today's webinar. You can contact Florine also via LinkedIn by scanning the QR code, but of course, you will also be able to contact him with the information that you will receive in your email after the webinar. Florine, welcome.
Thank you, Valeria. A warm welcome from my side as well. Good morning or good afternoon. It's my pleasure today to accompany you on the another vertical presentation that we do, and this time it's about office and commercial buildings. So let's start right into it. As we know, offices and commercial buildings have incidents all around the year, all around the globe. So we see here a couple of examples from the last years where we had fire in different buildings around the world. We see from Asia, we see from Europe, Netherlands, Switzerland, and of course, these are events that we would like not to happen. We would like to mitigate these risks. And therefore, we have to look into the specific challenges that this environment of office and commercial buildings sets up for this for our type of system. So let's start with these specific challenges. We have a very high occupancies, so usually the commercial buildings are offices combined with restaurants, maybe hotels, maybe sometimes, I don't know, different other types of areas we're going to see in a second. So that means we have a very high rate of occupancy. We have very complex layout, usually high-rise buildings, a lot of floors, connected buildings, usually underground parkings that connect multiple overground buildings, so very complex layouts. We have valuable assets. We can have data centers inside. We could have a lot of, let's say, different type of businesses running. And of course, it's very important to be compliant with the local and regional regulations for this type of buildings. So what are the consequences when an event starts or even happening in these type of locations? Of course, this could lead to loss of life, which is the most grave one, and injuries. We could have property damage, business interruptions. I think that's also very important. Even if it's not a manufacturing site, still there's activities going on in these buildings, and this can also lead to loss of property, data losses, especially if we have data centers, for example, and finally to reputational damage. So having this in mind, setting the context for this vertical, let's see what are the key goals for the safety managers, right? As usual, what we did, we discussed with a lot of integrators, a lot of end users, and together we decided, we looked at what are the most important factors. And from this, we extracted the 4 key goals for the safety managers of commercial and office buildings. And these are, of course, ensure safety. We need to keep the employees, the visitors, everybody that is inside these buildings safe. We also have to look at the assets, even they are material or immaterial, to be safe in the building itself. We need to avoid the disruptions. We need to avoid business interruptions for everybody. That, of course, can lead to loss of money and loss of property. We have to minimize the risk. When we're talking about fire safety, it's always about minimizing risk. Look at the possible causes, let's look about what we have to protect, how we have to detect, and so on, in order to minimize the risk. And finally, very, very important, because we are talking about safety and fire detection, we have to be compliant to the policies, be they regarding maintenance activities or general product specifications, whatever these are usually mandatory on a local level or regional level. So having this in mind, let's look at a typical office space, right, or commercial building. And we looked into detail about what are the, let's say, typical areas in such a building, but also what are the, let's say, necessary traits to address different challenges in such an environment. So looking at the areas, we have standard areas like office spaces, meeting rooms, apartments. So these are pretty much the standard application for a electronic fire detection system, right? We have sensitive areas with specific, let's say, more special needs like kitchens, canteens, smoking areas, server, electrical rooms, shafts, parking areas. So we're going to look on those in details as well. And we have also areas that do not have maybe functional requirements, but aesthetical requirements. And these are, for example, reception areas, lobbies, or retail areas in the commercial buildings. So having this in mind, we're going to look into details for all of them, but also some of the, let's say, traits that address specific challenges. And for this, we extracted the integration possibilities we have with a fire alarm system, remote maintenance, so we're going to look in this aspect as well, and also the concept of a modular system and future-proof system. So let's jump right into it. And we are talking um, first about the standard spaces, office areas. These are normal meeting rooms. And pretty much everybody knows about this type of areas. And you would think that this is a normal area with a low risk. But actually, there's quite a high risk, and it comes from two main factors that are combined here. One, it's a huge file load because of the furniture, wood, paper, documents, um, decoration, whatever materials that are in these areas, are usually highly flammable, right? This combined with a high density of electrical and electronic equipment that can be possible causes for a fire basically increases the overall risk for such an area. For that, of course, our solution, the Avenar fire detection system with the Avenar panels and 4,000 detectors, um, constituting together a very, very reliable and early detection system. That's very important. Two aspects, the reliability and the speed of detection. Another aspect that comes into mind with thinking about this is the e-smoke feature in our Avenar 4000 detectors, because this will allow us to basically avoid false alarms that could lead to interruption of business or activity in such places due to electromagnetic interference. So e-smoke is a feature that comes with all the Avenar 4000 detectors, allowing um, the technicians that and operators of the fire alarm system to see if at a level where the or the point where a detector is installed, we have a higher or lower, let's say, electromagnetic disturbance. And this, of course, um, will help us not even to uh, find the root cause of a false alarm, but even to avoid this kind of events. Right, moving on. Let's talk a little bit about reception areas, lobbies, and these are usually areas with high aesthetic requirements like false ceilings, different architecture, and this is something that usually um, architects are very demanding about the requirements of the equipment that's installed. And our solution is the invisible fire detectors, as we call them, the detectors with a visual optical chambers that will allow the detection with no compromise in safety, but with a very, let's say, minimum unintrusive and minimum visible elements on the ceiling. So not only that it's, let's say, very discrete, it doesn't have a physical optical chamber, but it's also being able to be personalized in different colors depending on the architecture. Right, so kitchens and canteens, I think the high risk here, it's obvious for everybody. Um, Still, maybe it's not very obvious when we're coming to the false alarms, possible sources like steam, for example, or fumes that are in the process of cooking. So we have on one side a very high risk due to the flammable and open flame in the processes, but also we also have a very high risk of false alarms. And for that, we answer with our Avenar 4000 multi-sensor detectors, which incorporate different type of sensors that together are working in an algorithm, also with an algorithm called ISP, or Intelligent Signal Processing, where all this data from these sensors are combined into patterns that are very fastly deciding if this is a real fire scenario or not. And this is very important. Yeah, on one on one side, not to evacuate the whole building every time somebody's cooking, of course. So we have to basically filter the false alarm scenarios, but also provide robust fire alarm. So when actually a fire scenario happens, to make sure that this is really fast detected and all the measures are in place. Right. Smoking areas is basically, I know it's dependent on the culture, background, territory, and so on, if this happens or not. But where it happens, it's also a high risk, right? Because, latent cigarettes are a fire source, of course, but also the smoke itself can be an alarm generation factor. For this, we also with exactly same detector we mentioned above, and due to these ISP algorithms, we can also filter cigarette smoke as a, let's say, false alarm source. So this is important. If you have such areas in your buildings, know that there is a solution also for these areas. Next on, if we talk about server, machine, and electrical rooms, data centers, or other similar type of rooms in the building, these are also high risk areas due to the density of the let's say, electrical equipment and fire sources. Think about also the batteries that are accompanying these equipment. These are also a very huge risk that can lead to a thermal runaway and a catastrophic event, right? So there's a risk of rapid spread and uncontrollable event if this is happening. So our solution here is a very, very fast detection method, the aspiration smoke detectors that can sample the air in the room, but also from within the equipment racks and analyze it for very, very thin particle, smoke particle presence in the sample there. And it also comes with the possibility of ISP, the intelligent signal processing we discussed earlier for the point detector. It applies also to the aspiration smoke detectors, right? So a really fast, very accurate method here to detect even earlier by sampling the air inside the equipment racks. Next on, usually especially in the high-rise buildings, we do have a lot of vertical shafts for elevators, for example, piping on electrical cabling. And these are, let's say, unusual spaces for the point detectors because usually we cannot protect them with point detectors, but we do have different other solutions like the aspiration smoke detectors that can run with the pipe vertically and sample the air at different levels in the shaft, or linear heat detectors that can run, for example, along cabling or other fire sources to, let's say, detect the heating or the rising heat in such areas. And this is, of course, a solution that can apply not only to vertical shafts, but also to other different tight spaces, like, for example, false floors or even false ceilings sometimes. Although in false ceiling, it's more, let's say, common to use point type detectors. Parking areas, here we do have let's say, a high risk due to the fire load, of course, may it be combustion engine cars or electrical cars. They are both, let's say, in the high risk fire load wise, and it's very important that we address this high risk accordingly. So there is our solution here is to, of course, protect the space with multi-sensor fire detectors. In our Avenar 4000 range, we do have different type of sensors, different type of detectors, including different type of sensors. And for example, in a combination of smoke, heat, even CO detection together, we make sure that this is a real fire scenario that is detected really, really fast and reliable. So we have different options here, of course. We can even go with a basic heat detector, but we can also go with multi-sensor detector. There's also the option to use Aviotech, our video-based fire detection camera, that will allow, let's say, flame and smoke detection at the source. We don't need the smoke, for example, to rise to reach a certain detector, but we just have the image analyzed and decide really fast, really, really fast, if this is a fire scenario or not. So different solution for a very, very challenging part of the commercial buildings. Retail zones, and normally here, of course, it varies from building to a building, that we could have this kind of let's say retail zones that can be maybe a combination, for example, with a small kitchenette and retail store. So basically, we have the same type of possible false alarm sources like steam or yeah, vapors that could lead to false alarms. Um, but in the same time, we can have very, let's say, demanding aesthetical requirements for this. So basically, we have a combination of factors, and our solution, of course, is the same invisible detectors that can address the aesthetical requirements, and of course, also the ease of maintenance, but also yeah, the multi-sensor detectors, if this is a, let's say, area that it's prone to false alarm due to different factors that we mentioned earlier. Finally, apartments, and here it's yeah, it's not usually that we have, let's say, lodging facilities in office buildings, but in some parts, let's say, of the world, in some geographical region is more common than in the other, and we have to take also a look at this. Usually, the apartments are in the upper floors of these high-rise buildings. For this application, it's very important not only to detect fast and reliable with our Avenar 4000 detectors, but also to notify the occupants, right? Because usually the escape route is quite long for these apartments, especially in the top part. So for that, we will need these, let's say, signaling devices in most of the areas, and for that we come with the solution of base sounders that can basically fulfill the signaling role at the point, very close or even in the same point, with our all-in-one solution for detection, but signaling also audio, but also visually. So we have all these options that we can use to address. It's a very common solution, for example, for hotel rooms, but this is mainly just a trait of that system applied also to office and commercial buildings. Right, so we saw different areas in the buildings. Now let's slowly move towards different challenges that require, let's say, specific traits for this vertical. And one of them is the integration need. We have an integration need to interface with different other systems like air conditioning, like lighting, security systems, energy management, and so on. Not only to not only to read data, but also to send data. So we do have an let's say bidirectional need of communicating. So for that, our Avenar panels are coming with different type of integration possibilities. And there are, of course, data integration that we can have and execute at the level of the controller in the fire alarm panel. And for that, via Ethernet, we can integrate with different systems via OPC, BACnet protocols, just to mention two of them that are standardized, but also via FSA, which is our proprietary protocol that is based on OPC. Both of them, OPC and FSI, being open protocols. Right. More than that, we do have the option to integrate on hardware level with different types of interfaces. Depending on the system we need to integrate. For example, we want to send the elevator to the ground floor. We want to cut, for example, the electricity in some parts of the building or in a specific room. We want to shut down gas valve, for example, to prevent even catastrophical event and so on. All these are possible via different type of interfaces, hardware, right? But also on the data level via the protocols I mentioned. Speaking about data and previous slide about integration here, let's talk a little bit about integration of the Avanade system into our cloud services. These are called Exospace File System Explorer. Currently, it is an evolution of our remote system and offers a few components for verifying, checking the system status, also via instant alerts, email, or via a mobile app, and also offers the possibility to access the system remotely for different operations, like, for example, remote maintenance, where you can check all the issues in the system, prepare all your materials when you go to visit for the maintenance site, even before reaching the site. You know already which is the status, what are the materials you need, prepare everything, and just go once at the site. It also offers, for example, remote programming. It's rarely used, but still there is an option if it's needed. And all these operations basically ensure that you, as for example, a system integrator that maintain a building, can use your time more efficiently, not having to make multiple trips to the location and for example, even disturb the employees that are working in an office space, checking the system once, then going back, coming back with the materials to exchange some detectors, for example. You just go in one visit and minimize the impact of the processes that are going inside the building. And finally, let's talk about the modularity of the system. I think this is one of the most crucial traits of a system in the office building vertical, because office buildings, the spaces inside are oftenly reconfigured, expanded, and rearranged. There's a meeting room appearing here, there's a wall coming here, and so on. And all this basically will change the needs or the demands from a fire alarm system. And for that, you really need to have a system that allows you this flexibility, this scalability also to extend. Imagine, for example, small retail area inside your building at the ground floor where stores are changing. That's a store that it's going out, another one coming with a different layout, and so on. You want to have, you will have a different owner that has to receive this information about his space and so on. So basically, our Avanade fire alarm system has this trait of modularity. You can always change the components. You can always add more components to it, scale it up if it's needed. And also, it's very important, we do have this backwards and upwards compatibility to ensure that you only need to add parts, but you don't have to exchange existing parts if it's not needed, right? So this is one of the most critical, let's say, feature regarding the Avanade system, the modularity, and also the fact that it's a future-proof system. So if we have to make a conclusion about what we discussed so far, we looked into these challenges. We come up with solutions. We came up with solutions about each of the challenge. We looked at what are, let's say, the key factors why Bosch is fitting this vertical. So we have extracted here 4 points. First one, reliability. Very fast and accurate fire detection is crucial in this type of buildings with minimal false alarms. We don't want to disturb the occupants. We want to have a smooth operation inside the buildings. Durability. Our products are made to last. We think these products, of course, usually outlast the requirements, normally the local requirements about the lifetime that's permitted for the operation. So usually, let's say the lifetime of the product or the let's say cost of ownership is also extended through this durability of the products that we offer. A future-proof system allows the system to be enhanced, adjusted, and this is because of the modularity and compatibility features of the system. And finally, additional services that are very important, like, for example, remote services that we offer, adding additional value to our system. So we have this, let's say, as a conclusion, and then I will move to the next part, which is basically to talk a little bit about the components of our system. And we see here, let's say, an overview of our system with a panel in the center with the Avenel panel, in the center with the controller and the modules. And normally we connect to this panel the addressable loops, the LSNI loops, that are composed of different hardware, different peripherals like the Avenar 4000 detectors we see here, or the Avenar 500 or the 520 series, the invisible detectors, aspirating smoke detectors, connectable directly to the LSNI loop, different type of interfaces like we see here, for example, for conventional detectors or wireless detector or special detectors, fire brigade panels or annunciators, floor maps that we can build with LEDs, for example, and of course signaling devices like sounders, sounders with flashes, all addressable, even as a base for the point detector. So these are the what we call addressable peripherals that are connected to the panel, and of course we have different other connection possibility, like for example the remote keypad that we can connect via the network, printers, for example, management systems, alarm servers, so on, dialers that can connect to the fire brigade, the next space remote services that are connected via a secure gateway to our cloud services, and of course different other let's say value adding components like the free programming software or free planning software, safety system designer, or Aviotech as complementary detection platform to the fire alarm system. So let's talk about the most important ones. I will not go through all of them, but I will touch the most important ones. And of course, we start with the brain of the system, with the fire alarm panel, and that Avenar panel that comes in two variants, Avenar 8000 and Avenar 2000. It differs in capacity. Of course, Avenar 8000 can go up to 32 loops of peripherals, 32 LSNI loops. Avenar 2000 with maximum 4 loops. Yeah, it's a very flexible system, modular system. We can configure it as freely as we want, add modules, add cases, different other models in those cases and so on. So basically, we can expand it also after commissioning. So that's a very cost-effective feature. We do have a very strong controller in this panel, processing power-wise, with a very, let's say, friendly user interface, with a big touchscreen, color touchscreen, with all the functions there. So we can basically operate with ease. And just as a side note, maybe the interface for that controller is the same with the remote operating panel. So basically, when we have a remote panel, somewhere in the building to operate is the same interface with a panel controller. So you don't need to learn different interfaces. You, as an operator, you just need to learn once, and then you can operate on any operating panels in the system. Avinar 8000 also comes with a full redundancy option. So basically, we can have two controllers connected, and one is working, one in standby. If there's a defect that affects the controller, of course, then the second backup controller will start up and take over the function of the system, basically ensuring nothing is lost as a function about the operation of the system. We have, of course, the possibility of integration, like we discussed. There is a 4 Ethernet port switch inside every controller that ensures the number of ports necessary to integrate with various management systems or other equipment as needed. And very important, also very clear language neutral notification on the left side with LED icons that are signaling the status of the system. So this is the Avinar panels. Next on, let's look at the peripherals a little bit, and we start with the Avinar 4000 detectors. As I said a little bit earlier, it's a family of detectors that can come in different flavors with one, two, or multi-sensors inside. That can be optical smoke, dual optical smoke, heat, temperature, or even carbon monoxide, right? So there is a combination of those that can be used for, let's say, optimal detection. It's a very fast detector and very accurate, thankful to this dual ray technology. Basically, the DO detector, double optical detectors, have two LEDs inside the optical chambers, ensuring there is a detection calibrated on a specific particle that we are looking for, ignoring, or maybe not ignoring, but not generating false alarms from other particles like steam, cigarette smoke, and so on. Also, this intelligent signal processing feature that creates patterns of the values from the sensors helps deciding very, very fast if this is real alarm scenario or a false alarm scenario. It contributes to, let's say, the speed of detection, but also to the robustness. We mentioned also the e-smoke feature, and this is the third mechanism that we use to filter false alarms. So we mentioned dual ray, we mentioned ISP, and now e-smoke. Combined, all three ensure you have a really, really robust detector. This detector also is able to transmit analog data and be monitored in the cloud services, enabling data analysis. Also is coming in two possibilities, at least some of them with manual or automatic address. And this is regarding the hardware address for the detector on the loop. Right. The second series of detectors, because this was Avenar 4000, the second series of detector, it's 520 series, is the invisible detector, as we call it. It has a virtual optical chamber. You see on the detector, you see the LEDs that are contributing to the detection, but the detection itself is happening like somewhere 5 centimeters below the detector itself. And this basically gives few advantages. One, it's non-intrusive aesthetically speaking. It can be personalized with a lot of colors, as you can see here with these color drawings, so it blends easier into the design, but also is very easily maintained. You just need to wipe the surface clean, and that's it. Talking about detection, we also have to mention the Aviotech, which is our AI-powered video-based fire detection. So it basically uses neural networks to detect, to analyze the images and decide if this is a fire scenario or not. It can detect really fast smoke and flame at the source. So we don't need, for example, the smoke to reach the ceiling. So especially important, like for example, for high ceiling areas. And the detection is also very fast. It's within seconds, um, including the, let's say, confirmation, not only the detection, but also the validation process. It's very suitable for where we have higher fire loads, yeah, um, or let's say different other particles that can, you know, um, let's say, make traditional methods of detection not suitable. And very important, it can also work in outdoor environments where not too many options we have, yeah, to detect fire. This is also a solution for such areas. Right. And concluding the detection part, we have to also discuss a little bit about our aspiration smoke detectors. We have quite a range of units with one or two detectors inside that can be connected straight to our loop, LSN loop. It's a very powerful, let's say, unit that it makes use of the same ISP like the point detectors, basically constructing patterns of signals and deciding very fast if this is an alarm scenario or a false alarm. It's very robust regarding the airflow monitoring and handling of the, let's say, variation in the airflow monitoring. Like for example, the thresholds can be moved with the pollution, or yeah, we can have a drift compensation for that. And finally, there is a range of products in this family that also can identify the sampling point that generated the alarm. So imagine you have, for example, a unit, a room with 5 rack rooms, rack cabinets, sorry, and you have a pipe that runs through all these 5 cabinets with 5 sampling points, and you can basically find out very early which of these 5 generated the alarm. I think this is very important in such a use case. Right. So since we passed the detection point part, let's also discuss a little bit about the signaling devices. And here we have to mention the uninterruptible sounders. So sounders that are coming with a battery inside that are ensuring the fact that if the line, if the LSN line is destroyed, still the data, yeah, it's not there, communication it's out, power voltage is supply, it's out, still the sounders will continue running for up to 30 minutes if it's separated from the loop. I think this is very important, especially keeping in mind the high occupancy rate for this type of buildings. It's important that we keep the signal devices running, even if there is, let's say, catastrophic event about the fire alarm system itself, and this is taken out of commission. Okay, finally, to conclude my presentation, I want to present you two references we have. And the first one is coming from Croatia, from the Grave Insurance, which is the one of the oldest insurance suppliers in Austria that has 62 offices across Croatia. And yeah, the challenge here was that unreliable fire alarm systems were keep disrupting the tenants. There were a lot of false fire alarms, and this was leading to disruption, right? So we installed our Avenar 8000 panels with Avenar detectors and connected with Nexus Space. And this is basically the answer to the solution. No more false alarms due to Avenar, and of course, very, let's say, prompt control of the system to the connection via Nexus Space. The second one, in Warsaw, in Poland, Central Point, 21-story skyscraper located centrally. Also, very important here was the connection to the, let's say, public address system via Smart Safety Link, and also minimizing false alarm was a key, as it was not a problem addressed because it's a new building, but it was a key point in selecting the right supplier for the fire alarm system. Also, very important, it was the modularity and flexibility in designing the office layouts and the scalability to extend it even after the building was starting operating. So, just as a point of what's reference, what it's possible to do, there are of course many other references, but we just picked these two to pick your interest. And I think I took a little bit more than I should, Valeria.
It's
It was
okay.
not that
It was
boring.
interesting, the presentation.
Yeah,
So yeah, so thank you for that, Florian. Again, here is Florian's
my pleasure.
LinkedIn account so that you can reach out to him in case you want to contact him directly. And before we move forward to the questions, we have a couple of them already in the chat, but I also want to give time for people to just write down their questions. I would also please ask you to scan this QR code in the screen and just answer a very quick survey. It is very important for us to receive your feedback, so please take some minutes to do that. I will go back to this slide. But I also want to make a quick announcement. We will have a next webinar on December 4th. This is regarding protecting heritage, so how to overcome fire safety challenges in public and historical sites. So bear that in mind. We will also send you the information on the on the email that we will send with the information and the recording of this webinar. So I just wanted to show you that this was going to happen. So now to the questions. Just one second. Do we have also solutions for e-cigarettes? We see more and more inside buildings.
All right, that depends on what the solution follows. Do we need to detect emissions from e-cigarettes, or do we need to filter them out as a false alarm? So for the first part, no, we normally do not detect e-cigarette smoke. So for that, we normally avoid false alarm produced by e-cigarettes. Of course, um, we cannot say that we tested with all types of e-cigarettes on the market, but usually cigarettes, normal cigarettes, and e-cigarettes are addressed with our dual optical detectors that can filter this as a false alarm.
Perfect. Another question. Can we add third-party repeater in Avenar panel?
Right. Usually repeaters are part of the system, and our repeaters are operating panels that can be added in the network with different other panels, and normally are Bosch equipment. So what we can add as customized equipment are, let's say, panels that are signaling different states via LEDs. These mimic panels that usually are connected to the loop, and these can be custom made in any shape or form that addresses the needs for a specific project. So this we could add, and we can also connect to third-party softwares that are having this, let's say, function of signaling or visualization of the status of the system. So basically, it's kind of a um, same function, but physical hardware repeaters in the traditional way, only Bosch equipment can be connected to our panels, of course.
Perfect. We have another question here. When using the FAP 425 OTR, FAP 425.R only as a thermal detector, does the optical part still monitor for contamination and report a fault in the chamber?
Right. Uh, so very technical question. Normally, yes, that should happen. Yeah. But the also what is reported, it's not let's say prohibiting the detector to function normally, right? So that could detector can function as a heat detector without any problems, even if it's an OTR that it's set as a heat detector. Yeah.
Good. Then, can I use .co for underground parking spaces?
Right. DOTCO is a multi-sensor with dual optical heat and carbon monoxide. It's very fitting for parking spaces, of course, but we have to make a very clear delimitation here. It's very fitting for detecting fires in parking spaces, but it's not, let's say, fitting for detecting um, technical CO alarms in parking spaces. We have to make this difference between fire detection and technical CO detection. Our detector um, is not intended in this use case to be used like this. So we recommend a dedicated system for that. Purpose if we're just looking at accumulation of CO. But fire detection wise, it's very fitting because of the multi-sensors. It can basically be very accurate. It can basically, it's very tuned with the ISP on the real fire scenarios. So yes, can be used, but just for fire alarms, right?
Okay. And what interface models can you recommend for monitoring and controlling fire dampers?
Right. So we have quite a broad range of interfaces here. Hopefully this is coming from somebody who knows the product range. So we have the RHV interfaces that can be used, but we also have the new I2M1 interfaces who were recently launched in our portfolio, very fitting for damper control. Um, Also very important, we're having an upcoming product soon to be launched, the i4R2, which can control also fire dampers, also smoke dampers, and I think there's quite a broad range you can select from at this point. So quite a lot of them.
Perfect. So, Florin, it's time for us to say goodbye. Again, thank you everyone for participating in today's webinar. I invite you again to join our next webinar. It's also available for registration on our website under the webinar section. And once again, please subscribe to our new newsletter and follow us on our LinkedIn channel, Bosch Life Safety Systems. Thank you everyone very much. Have a good day. Florin, thank you very much.
Thank you also from my side. Have a good day.